It is called waveform collapse. And let's say that this here water molecule that I've got highlighted right here, let's say it's the one that got hit. Actually, there's three of them getting hit concurrently at the same time. That's a whole other topic of discussion that we'll have to cover later. But let's say this water molecule, number 17, was struck. Struck is kind of like a term that's not as straightforward as it sounds. But if this is the one that was struck, then what would happen is the universe would figure out how much distance it has traversed. In this case, it's traversed what? 1, 2, 3 Planck distance units. And it would go ahead and take that into account. It would square that number and divide that into the intensity. It would add that to the heat level of the particle. And I know you don't know what I'm talking about when I say heat level, but in the first book in this series, I go ahead and describe a data structure that the theory of everything uses to define all the particles in the universe. And one of the attributes of that table is heat level. So there's a heat level, it's just an integer number, and when an absorption takes place, which is what's happening here, then some of the heat from the photon is imparted onto the molecule or the element that got struck, right? And the universe at that juncture can go ahead and delete any intermediate data structure it has constructed thus far. In this case, it would delete this photon Q record right here. Oh, this one right here, I'm sorry. And then it would go ahead and continue on. That's how my system, my T.O.E, transmits light from an emitting particle directly to an absorptive particle, okay? But typically that doesn't happen. Typically, instead of hitting an absorptive particle, typically it's going to go through some transparent particles along the way. And that's actually what I've got shown here. The stuff that's all these water molecules here, I'm considering them all to be transparent. So here's what happens in that case. When a photon strikes a transparent molecule, the T.O.E behaves differently. It doesn't absorb it, and it doesn't collapse the waveform. Instead, here's what it does. It treats these, all three of these, like these are three potential absorptions that happen, but they're not going to be absorptions because they're actually transparent molecules. All three of these happen concurrently. So what the T.O.E is going to do, for each of these, it's going to act as if it's a brand new emission occurring from this location. Another one occurring from this location, another one occurring from this location. So where the photon Q before this tick looked like this, there was only this one record in it, right? Well, now it's still got this one record in it, but now the T.O.E went ahead and added these three new records. I'm calling these intermediate photons because they're not photons that originated originally from a emitting piece of matter. They're sort of intermediate photons that got emitted when when an in progress photon struck a piece of transparent matter, and then it's going to act like a brand new emission from this place. So there's going to be three of them in here: one for this one for that, and one for that. Okay, and the universe is tracking all this in the photon queue. It's informationally tracking the pathways that it's potentially taking here. All right.